Okay, now it's online. Now.
Okay. Sorry, say that again, Zach.
Yeah, go ahead. Your
Yes,
topic is the first one, so you do it first.
All right. All right. I sent the link to my code in the chat. Hopefully everyone has that open.
Yes.
Cool. All right. So I put them all in one folder, which is fine. I mean, I could separate them later if I wanted to. What you're going to need to do when you do Java collections is you're going to import the java.util, and I just did asterisk so that everything's updated, the maps and the lists and the sets, everything, and the iterations. So when you go into Java collections, it is basically a set of objects and classes to make data coding essentially a lot easier for you. The first one is the list collection. Yeah, list collection. That's what it's called. And it's basically the array list, just how to make an array. So as you can see, in the first one, it just says array list, and I made it the type string, named it cities, new array list string, and I just put some simple cities in there. And then I did cities.add Colorado Springs. That's how you add to it once it's created. And then you can also remove it, cities.remove, remove Cairo because it's not a United States city. I was just keeping it simple. And then you can change the index number. So this is what makes arrays different from hash sets and hashes, is that the array list lists things by index. And so I said at index 3, and make sure you remember that it starts with 0, change it to Idaho Falls. And so in the output, I don't have output on here, but when you run this code, it'll change that to Idaho Falls instead of, in this case, it would be, it would add it actually right after Rexburg, because I don't have a third one, but that's fine. So you can also use, if you don't know the name of the city, but you want to look up an index, you can use cities.get, which city is just the name. So you just name of the array.get and you put the index number, and that will show you what city name is at that index. Now we move on to linked list. Linked list is a little bit different because the array lists everything by index. The linked list lists everything by, they don't have an index per se. What you can add an index to it, but it's not necessary. What they make it, how it works is that the first item is the head of the list, and the last item is the last. So this has been updated since then. I was trying to find the reasons for why would you want a linked list versus an array. And it used to be an array, you couldn't add the first item, you couldn't change the first item of an array. You couldn't do that before, but now they've updated it and there's almost no reason to do a linked list at all. Whatever, but I did it anyway because it was part of it. So what I did notice is that you cannot use the as list to display them all at once, like Littleton, Boulder, and Rexburg. You have to add them one at a time by using .add, which is really annoying, which is another reason why I hate linked lists. And so I just used some tools at the Home Depot, and I added and removed and also outputted my my output there using systemout.println. Then we move on to vector, which is a global array, which basically has initial capacity and you can increment the growth. I was trying to figure out why you would want to use this, and mostly it's just to limit your data. If you want to, you can also put a cap limit on it. So I guess that's the point of a vector. Other than that, it works pretty much the same as a linked list. You have to use the .add function to add items in, which is extremely inconvenient. Or you can do there's another way around it. You can do a nested, what's it called? I think it's, you can use a nested as list, and it will also work. And then show me some examples of that, but I just didn't include it here. So basically, when you exceed the amount, so initially the capacity of this vector was 3, and I added 0, 1, and 2. Once I add that item 3, though, what will happen is the capacity will increase by the growth increment, which I outputted in at 6. So what will happen is it'll go from a max capacity of 3 to a max capacity of 9, because it'll increase by 6 each time it exceeds its capacity. I know it's confusing. Do you have anyone have any questions so far, though?
You said 9. I
Why-
thought it's 6.
No question for me.
So 9, it went from, because it started at 3, and you just add
Mhm.
6 to it. Does that make sense? So now it's 9.
Wow.
But the increment is still 6. It's just now the capacity is 9.
Okay, why the increment is 6? It's just double the.
I think it is the default is double the capacity, yes. But you can
Oh,
change, you
okay.
can set the increment by just in the parentheses, do 3 comma 1. Yeah, well, you can't do 1 because you can't have less than the capacity. Well, actually you can. It would just increase by 1 every time. And depending on what you're doing, I guess that could be a good thing.
Okay.
So you just do 3 comma the number of the growth increment. It's a little weird.
Mhm.
Yeah. Okay, so that was the list collection. Then there's the hash collection. Hash set is similar to an array, except you can't use list as again unless it's nested, and you have to add them separately then. And the weird thing about hash set is that if you input data in, it's going to, and you want that data displayed, it will display it randomly. Which, again, I'm wondering why the heck you would want that. I honestly don't know. It's boggling my mind. Anyway, when you output this, it'll show, I think it's apple, grape, peach, orange, or something. And I was like, okay. And then there's the linked hash. The difference between here is that depending on the order that you put it in, it will display that order in the output. So if you do A, B, C, D, E, F, it will display that as A, B, C, D, E, F. And it's pretty much the same as the hash set other than that. And then lastly is the tree set. The tree set organizes it alphabetically. So I did a bunch of toys and it will alphabetize them. And I also did numbers and it will go from negative to positive in greater value. So lesser to greater. And that was the hash collection. The map collection is similar to hash, but it maps data using a key to value pair system. So what'll happen is when you input data, you'll say, it's kind of like an index, but it's not because it doesn't increase incrementally. It's whatever you state it to be. So as you can see, hash map, I said the value is 87. And when there's a value of 87, I put a string as the number 87, but I could have put anything in here. I could have put bicycle. I could have put car. I could have put anything I wanted into there. Florian's calling me. I'm not really sure why.
He's calling everyone.
What do you want to do, guys? Is he not in the group anymore?
Yeah, he's not in the group anymore.
Oh, dang it. Well, he's calling my tablet, which doesn't really help the situation.
We could just say we'll put up the video afterwards and go to bed.
Yeah, I don't know what to do. Why don't we just... Oh, crap. Well, I don't know. If he calls again, I'll answer it, and I'll tell him that Edvaldo will send him another invite. Or actually just do that right now, if you can, Edvaldo.
I sent an invite again for him.
Okay, cool. Thanks. All right.
Welcome.
Well, at least he'll have the video. All right, back to the presentation. So you can input anything as the value, and you can also put anything as the lookup pair to that value. And then when there was I believe it was the tree map, and the tree map basically does the same thing as the tree hash, except it uses the value and pair system too. So it'll just list it by alphabetical or number order. But the difference being, it does it by the value instead of, it does it by the index basically, or the value, the left-hand side. So the 87, the number, not the text. It'll go by that instead of the output, which was weird. So when I did the tree map number 2, I was testing this out, and instead of A, B, C, D, E, it said C was first because it was least. Then it went to B, so it was weird. No, it went to E then, and then it went to B. So that's interesting with the tree map. Let me see. And then there's iterations. Iterations is basically just a loop. That's really all it is. So it's kind of like a for loop. You say while or actually it's mostly like the while loop. So, well, actually you can use for or while in here, and I could show an example of that if the instructor asks me to go a little bit deeper. But you can use either one, and it just loops until it doesn't have any more, or you can also use has. So has next will go until it runs out. Has previous will go until it goes to 0. So that's interesting about that. Oh yeah, I forgot about the linked hash map, sorry. The linked hash map is the same. It will import them in the order that they are inputted into the map. So in this case, when you output this, it'll just be ABCD. And then there's iterations, which I explained were just a loop. There's 2 types of iterations. There's normal iteration, which is standard, basically a loop. We can use for, while, on. And then the list iterator, that's when you can use previous on that. As far as that website I was on, I'm pretty sure you can't use previous on the normal iterator, or it just won't work. And that's finally the end of my presentation.
Thank you.
Okay, very good.
Thank you, Jeremy. I actually have a question. Usually I just do like PHP and JavaScript kind of programming. So I just wonder if it's possible to have that kind of array, because like in PHP or JavaScript, you can have a very complicated nested array in like different kind of data types. Is it possible in Java?
So you're asking is it possible to do a nested array in Java?
Yeah, and also like mix all kinds of data type. Because I see
you can leave the data type. You can leave the data type blank, and it will. I believe it will allow multiple data types. Yeah, but I know that to be true, but I'm not sure about the. I would assume it would allow nested data types in Java. I haven't done that in a while, so I have to look that up. But I feel like most computing languages can.
Because apparently when you say the array list, and it's basically only by index, and which map? It's like a hash map, or
the
maybe
hash map does the value and pair system. Yeah, that's what
the key value. So
yeah.
it's still very like restricted to like what kind of array you want. Instead of like PHP, you can pretty much, or JavaScript, you can throw in whatever. You can have even have like index and the key at the same time, and then of course the index will turn into the key. But this is not possible.
Yeah. You can. I know you can add an index to a hash, linked hash, but I'm not sure if you can add it to the maps. I'm not sure on that. I have to look at it further.
Okay.
Yeah, I'm not sure.
Again,
sorry.
Thank you. It's been like forever. Like I did some Java like development long time ago, so I don't remember a thing. So
yeah, I'm kind of in the same boat. I took the class like a year ago. It's not that long, but some things have faded, so I'm like refreshing on a lot of things.
Okay, anybody else? Any questions for Jeremy?
I got a question.
Sure.
This is not really about your code, but when do you plan on passing this off to the teacher?
I was actually going to wait because I don't want to waste his time. So I'm going to do another one and then I'm going to submit it. So I'm going to do another one this week and then I'm going to pass both of those off. That was my plan.
Okay. So did you have 2 for this week?
No, but we have to think about that because time's running out It's already week 2, so there's only 8 weeks left. Well, actually 7 now because of week 3, right? So there's gonna have to be weeks where we do more than one. There's gonna have to be just to finish it off. It's gonna suck.
Oh, sorry, I'm yawning. Someone else yawned to the mic. I blame them. What do we want to do regarding that? Like, because I don't see like it doesn't make sense to go past something off we haven't discussed in the group, because then we're not on the same page.
Oh, well, what I was going to do this week was I was going to pass off what Zach did. Well, I was going to plan on learning it, but I didn't have the time. So usually the plan was to whatever 2 things we're going to do, everyone does those 2 things so that everyone stays,
Right.
That's my plan. It doesn't have to be your plan,
No, that's what I was thinking. I thought you were saying that you were going to be two of your topics this week.
Oh, no.
Okay. That sounds like a good idea.
Oh, dang it. We lost him again. Crap. Oh, well. He just joined. Oh, dang it, man. He must be having bad internet.
No way. It's very good. He's very welcome to our meeting.
No, I know. I'm just saying maybe he's got bad internet or something. I don't know. Oh, you're talking about my baby. Sorry. Anyway, go ahead, Zach.
Why is flashing?
That is a good question. I don't know.
You're trying to hypnotize us.
We can just look up you already sent us our code. I already have it open, so just go with it.
Yeah, well, actually, because my code is not good enough, no comments. So actually, I made a presentation.
Oh, did you? Oh.
Okay, we
there we
found this. The wrong screen actually. Let me try this one. What? It just won't work on this one. Anyway. Oh yeah, sorry about that. It's the chat from my girlfriend. So. That makes sense, right?
That's all good.
Okay. Okay. All right. Oh. So threads, runnables, and executors. So not this threads, but it actually works very similar. So if a single thread is only the main thread that works, then if we have 3 tasks, everyone, the task 2 will wait for the task 1 to finish, then to do, and then it'll be task 3. But if it's like multitasking, that means the task can run at the same time. I think everybody knows that. I just want to include it. So to create a thread in Java, we just need to, this is the easy way, just extend it and extend thread. And in the method run, you can put whatever you want to run in while you execute the thread. So here we just want to like spit out the hello from a thread. And then in the min, which is start this thread, pretty much start itself. So it's easy. And after this presentation, I'll show the code, how it runs, and I'll explain further. So the part 2, and let me see. Here, if we do this thread dot current thread dot get name, we'll be able to see. Actually, let me do like the demo at the same time. It's easier, I think. So here I have, should be this one, yeah. So I have the first file, and right here I just need loop it 3 times, make the thread 3 times, and let it run. Let's just proceed. And here in the run, it also loop 3 times. So it's supposed to run one task 3 times, and here, and between them there's a sleep of ½ second. So you can see that there are 3 threads there to work on the same task. If I actually go back to my class, and if we just try to output in the min of the current thread, you actually see the thread ID is min. That means it's not a sub-thread. Yeah, next. So runnables is pretty much just a reusable object for a thread. You can create your own runnable objects and runnable class. And run it in the thread. So here, just that's how you implement the runnable. And of course, you also need a run method to include everything this runnable needs to do. And in another class, you can call it, or the same class, that's fine. But you can call it and create a new thread and just let it start. Here I have my thread runnable. Here is the runnable. It's just a totally separate class, and I just need to design a run. This part, just ignore it right now, because later I want to show something else. That's why I put this part here. So go to my thread runnable. So right here, I just do a new my runnable. So you will just create a thread and throw in the runnable and let it run. Let's do it here. I think one of them is still running in the background, but it's fine. So same thing, 3 threads with message. Just ignore that part. Later you will have some meaning. Next, part 2. Let me see, what is it? Yeah, just this one is you actually call it within the runnable, but this one is called from another class. It's pretty much the same thing. It just depends on how you implement it. The executor. So this is a definition from Oracle.com. So the executor is a simple interface that supports launching new tasks. It's a little bit like I don't remember the name, but I used to do a little bit development for iPhone. The Objective-C has a very similar thing. It's like a text controller or something like that. So basically, executor is just a controller that help you manage all the threads. And so we have executor and executor service. The difference is the executor service can run not only the runnables and also the callables. Later, I'll explain the difference between the runnable and callables. The scheduled executor service it's just you can schedule when it will start and something like that, just like you have a scheduler. So to create a executor is very straightforward. Just executor and executor, and you create a new pool, and you throw in a runnable, and it will just start to run. Here, which is the first one? I think it's this one. Yeah, so here is pretty much the same code. Same thing, we'll do 3 times. We'll create 3 threads. But here, instead of just say thread 1, 2, 3, you put like pool 1, and the pool 1 is just showing you is actually managed by an executor.
Hey, Brother Zach.
Yeah.
Excuse me, but maximize your screen, please.
This?
Okay, thanks.
Okay, yeah. Sorry about that. It's just easier for me to switch back and forth. Okay, let's go back to the. So next will be executor service. So pretty much everything looks the same, except here you execute the runnable, but in executor service you actually submit the runnable or a callable. So same here, just very similar. I actually made a different one just for the service, but you can see it's pretty much the same except the name, and also you submit. Actually, if you use execute, it's the same thing. But I have not tried if you use execute with callable. Probably not going to work, but yeah, just don't risk it. So if you run it, this is the result. It's pretty much the, okay, there's an error. You run with all, oh, here, because actually this is a new single thread executor. That's the one of the very neat function of the executor, because you can control the size of the pool. And if you just create a single thread pool, that means it just single is going to be have only one thread. So despite that I executed 3 times, you use only 1 thread. So here, if I change it to, I think it's create cache pool. Oops. Create, or let me see. I don't remember. New, just new cache pool. So if I put here, if I put like, for example, 2, and let it run. Oops. Okay, just ignore that part. I'll figure it out later. But again, you can control the size of the pool. So it will run with the size. But the next part is important, is the callable. Where is it? Where's the PowerPoint? Oh, here. So is the callable. Callable is pretty much just runnable, except you can actually receive a return, because for runnable, there will be no return value. At the first, I was thinking like how you can actually return a value from actually the future, because you don't really know when the thread will be ended, and actually return and value. And it has a actually the callable works with a class is called future. So here it's almost everything is the same, except it has a return. And this part, the throw exception, is just added by Eclipse. It says you better put it there. I'll just put it there. So yeah, so here, let me do this. Do the example. Okay, this example is this executor service 4. Oh, it's actually a new fixed thread pool for the service. That's why it didn't work. It's not cached. So here I executed. I make a pool of size of 4, and I wanted to run 1,000 times. And if I run it, you'll be able to see that what works from it should be 0. 0 is here actually. 0 to 999 with only 4 threads. So with this, of course, if I change it to 5 and let it run, you will see another thread, thread 5. Also to notice is the program is still running. Actually, it's not like the threads, it will just end and the program will just close by itself. The executors need to be closed. So yeah, that's something else. But right here, let me switch this. This is runnable. Let me switch this. I'll just come in and out and switch it to callable. And let's run and see what happens. Okay, so one actually output future done false and future done true, and then the result. The results right here is 1001. Right here, the future object will receive an value from the callable. You can check if the callable actually is done by just doing this. My future dot is done. Of course, when you do this, it will just output false. And if you actually try to get a value of this integer result, get a value. Oops, why? Okay. And the result will receive when that callable is done, and it will just get the return value. I realized that if you do this, the integer result equals to, that will actually make the min thread like, how to say, occupied, or just like it will wait for it. It will wait for the result of that callable. So that's something need to be careful, because if you don't want to wait for a thread to end, and if it never ends, your min thread will just stuck there. And then when the result actually received, you'll be able to print out it's done, and the result is 1001. So that's callable. So basically, just one difference: callable give you a return value, but the runnable, no return value. And also, you need to use callable with the executor service. Yeah, so let's go to the next page. Next will be the scheduled executor service. So basically, you just do executor.schedule, and you put a runnable or callable there, and you put a delay and the time unit, and it will run when you want them to run, maybe like 1 second after, or maybe 1 minute after. So here is a very simple example. Here creates a new scheduled thread pool with size of 3, and we actually make a runnable object of task. It will just output the time, so we can actually see when this runnable will run, and we execute it 3 times and schedule with 1 second delay, 2 second delay, and 3 second delay. And I also have right here schedule here. So let's just run, and I'll explain the code. Okay, here on the third one, I actually get a future object out of it, and with this, you can actually print out how many delays left. So here, the remaining delay is almost like 2 seconds, because here I make the min thread just sleep 1 second, and after that to execute this, and of course it will be roughly 2 seconds left of this, because here we wanted to wait for 3 seconds, and after another second we check again of the delay, and it spit out roughly 1 second, is 996 millisecond, because the min thread has delays, of course. And here, the task 1, 2, and 3, the output will be, this one is a task 1, task with 1 second delay, and this is the with 2 second delay, and this is with the 3 second delay. And here we can easily tell the difference, because just the seconds there. So that's the scheduled executor service. Let's go back here. And I also attached a reference where I found all those information. I can share this PowerPoint with all of you guys, and if you want to, get some information. The last one is super useful. I didn't include everything from this this page. I think it's too much, and also too much for me. I still trying to remember how the Java works, but pretty much that's it for the presentation. Also, I think I've done everything. here. So yeah, questions?
Well, I do have a question, Zach.
Mhm.
We're gonna be making. I try to think of this when I was preparing my code, which is hard to think of. But we're gonna be preparing some sort of application or program, right? What are some
Yes.
things that we learned that you might implement in the program that we're gonna make? I mean, it's hard to know exactly because we don't know what we're making yet because we haven't decided. But what are some things that could be useful?
Well, multi-threading is very useful. For example, if you want something run in the background, as easy as let me turn off the screen sharing. Yeah. So let's one example is if we want to play a music in the background, and then we at the same time the same program want to do something else. But if only one thread is there, the main thread, the music will play and everything will stop until the music's done, and that just removed from the memory, and the next task will start to do. So multi-threading will help you solve problems like that. It's just like some kind of background service needs to be done. There can be a background music or background communications with the server. I think one of the very like a negative example of multi-threading is Firefox. Personally, my experience with Firefox is not very good. I love Firefox, but the multi-threading with Firefox is very bad. When you open like a huge website, the huge website usually has, because when you load the website, it has multiple different kinds of media. It can be pictures, flash, or music, and different kind of things. So by basically just doing, if you open up the text manager, you see like tons, like 20, 30 different threads in the, well, it run differently. And it's not really this kind of threads, but it's very similar. So Chrome basically run different things in the background. So when you open one website, maybe thread one is pulling those photos, and the thread 2 is trying to interpret those HTMLs, and thread 3 is trying to load video. So nothing will be like stuck there. But Firefox sometimes, if like there are too many pictures, the page will just stay there and blank, and the whole program actually freeze there. And that's a very negative example of multi-threading, because apparently that's just that the main thread is somehow occupied or stopped by some task. And that's what you don't want the user to have, that kind of experience. User want to have very like very smooth, everything is smooth. They want to click on something happen. So they don't want to just like click on something and they wait forever for the text 1 to finish, and then the text 2 will start to work. That's, yeah, I hope I explained it right.
No, you're fine. You're fine. That makes sense.
I feel like your stuff was more for bigger programs that you're like crunching data. Like example, setting the timer and then like it goes on, X amount of time afterwards. That could be uber useful in a company where you don't have like a cloud or a mainframe or anything, and you have to run stuff when you're not at work. So I'm not sure about a class. I don't know if that stuff can be very applicable for us, but I can see the application in the actual field.
Right. Yeah.
The multi-threading?
Well, no, not the multi-threading. I'm talking about the
timers.
Executor scheduled.
Oh, right. Scheduled. Oh.
I'm talking about that one little bit kind of stuck out to me.
And stuff. Yeah.
Oh. Yeah.
But even still, we never write massive programs in school. They're always, I mean, a lot smaller than what they are in like
real life. Yeah.
Yeah, in the corporate world. So.
But are we supposed to incorporate all these things into our final?
That's the thing. He said as many as you can fit in, you get a better grade, essentially. That's what he said. So I've been
boy.
trying to think about how I'm gonna incorporate this. And mine was easy. I can make an array. Boom, done. You know, that's not hard. Definitely ain't using hash set. Screw that. But I'll put an array in there, and that should be fine.
It has to all work into one, right? Like you can't just have a separate text page with it going or
I don't know actually. Because when I took 261, this is a different teacher, but the same method. Because professors just copy each other.
Yeah.
And he said it doesn't really have to work that well. He just has to see progress in the application to give you like a good grade. So it's also a thing to remember.
I don't know. I'm just confused because are we writing it all in one huge long file, or can we just write like it out separately, show that like we can write it can work? Like,
from what I understand, we have to compile all of our work together into one file and run it. That's what I think. From what I understand, I think that's right. We might have to ask the teacher when we do a presentation or our whatever you call assessment.
great.
Yeah, it's hard.
Well,
Yeah, you can finish the recording. I think that's
Yeah, you
everything.
might as well. That is everything. Yeah.
okay.
So I guess.
Just a moment.
Yeah, go ahead.
I finished the recording, but we can continue to talk. Okay?
Huh?
Okay.